Hello and welcome to the final video in our series of predictive maintenance with Splunk. We successfully ingested our OT data and designed a secure architecture. Now it's time to turn that data into prediction and ultimately into action. Now that our clean normalized data is in Splunk, we can begin exploration phase. An analyst will start by really understanding the dataset, identifying which metric relates to which machine components and recognizing how those metrics typically behave over time. We use techniques like standard scaling to normalize values to a common scale and event windowing to make sure we're looking at the full maintenance cycles, from a machine running perfectly to the point of failure. This step is absolutely critical. By correlating data feature with real-world wear, tear and failure trends, we build a foundation for accurate predictions. Once we understand our data, we can apply proven analytical methods. For predictive maintenance, there are three main approaches. The first is anomaly detection, where we establish a baseline of normal behavior and then measure any deviation from it. The second is unsupervised learning, which is great for finding natural clusters or patterns in your data when you don't have labeled example of failures. And third one is supervised learning, where we train a model using historical data that includes labeled example of both normal operation and failures. The right technique depends on your specific problem and dataset. Splunk has built-in analytics and machine learning toolkits to support all three. This brings us to the final and most important phase, closing the loop by putting these insights into action. The predictions we generate can be integrated directly into teams use every day, like dashboards, reports and alerts. More powerfully, we can trigger automated workflows in your maintenance system, like a CMMS or EAM. Imagine automatically generate a work order when Splunk predicts a component is likely to fail in the next 48 hours. The goal here is to share these results with operation teams to drive decision moving your organization from reactive firefighting to proactive data-driven action. So let's quickly recap why Splunk is such a strong platform for this. It's a unified platform that handles all types of OT data. The edge-to-cloud architecture with Splunk Edge Hub simplifies data collection and processing. It offers industrial-grade scalability and has a built-in AI and machine learning tools, so you don't need third-party plugins. You get security and observability in one, combining operational insights with your super security posture. And finally, its flexible deployment models and fast time to value mean you get results faster with less engineering effort. In short, Splunk reduces friction, increases insights and accelerates your journey to true predictive maintenance. Thank you for joining me for this series. Now you got the power to turn raw OT data into action. Not feeling unstoppable yet? No worries, we are just a message away. Happy building!